Hi everybody. Thanks for being here this afternoon. I'm Anders Wallgren, Chief Technology Officer at Electric Cloud, and I'm going to talk about software and software pipeline architectures and why they matter. Not that we really need to be told that, but every once in a while it's good to be reminded. I have a little bit of an agenda, an official agenda, not a hidden agenda. Although I have that too. So I'm going to start out with just a little bit of context, same as I always do. Dig into kind of software architecture and why it's important. Talk about why loosely coupled architectures, mostly what we call microservices for the most part, why they've become so prevalent and some of the problems they solve and some of the problems they cause. Talk a little bit about a few patterns out there to help with, especially with transforming monoliths into more loosely coupled systems. Talk about why the software pipeline architecture is also important. I've got a page of resources, just all the URLs that I stole all the pictures and the text from, basically. And then a little bit of Q&A at the end if we have time. So a little bit of context. Everybody's probably heard this by now, right? Software is eating the world, Mark Andreessen famously said a few years ago. And all of these industries here and more, we're living through software, right? I mean, that's how we're differentiating, that's how we're competing. You'd have a hard time today buying a washing machine that doesn't have software in it, or a refrigerator that doesn't have software in it. I don't know what percentage of car recalls these days are for software, but I bet it's pretty high, right? Yeah, and usually the way we do a software recall, unless we have a Tesla, is you drive your car into the dealer, and the guy that gets paid $120 an hour puts a USB stick into some USB port somewhere hidden in the car and updates the firmware, which I like to call the most expensive deployment in the world. Also the most inefficient and annoying. But so that's kind of what's happening, and then sort of more specifically, software is eating my bank. So I came across this as part of we did one of our C99 episodes, and this got brought up. So basically, this is all of the startups presently, I believe presently, in the process of trying to disrupt banks. In this case, if you look closely, you'll see that's Wells Fargo's homepage in the background there. And I haven't counted, but there's probably about 100 of them out there. So disruption is happening, right? And in fact, software is the primary driver of innovation and disruption in almost all industries today, right? I mean, ask a cab driver what they think about that. Ask musicians what they think about that. Ask filmmakers what they think about that. To be competitive, we need to deliver better software faster. We all do. So what's the one question that we can ask that will predict software team performance with startling accuracy? And this is from the State of DevOps Report, and the question is, to what degree do we fear doing deployments, right? Now you can substitute for deployment, you could say release, or burning the firmware into the chip, or whatever final form your software takes, whether it's on a website, or it goes in a phone, or it goes in a chip that goes to Amazon to get sold to someone, all of those kinds of things. So to what degree do we fear those? And the State of DevOps Report for the last few years, and if any of you have not read any of them, I encourage you to please do so, because they're great. Tons of data in there and some pretty careful analytics. Most of these numbers are from last year's report with a little bit of an update, an interesting update from this year. But the startling outcome here is that high performers are way outpacing low performers in the software industry, right? We're not talking percentages, we're talking orders of magnitude of difference, right? In this case, see if my laser works. No, that's not gonna work. I'll just point to my screen and you'll have to know what I'm pointing to. So 200x more frequent deployments, difference between high and low performers. 24 times faster recovery from failures, the high performers versus the low performers. 3x lower change failure rates, right? 2,555 times shorter lead times. That's probably the one that hits, a lot, right? Because that's lead time. That's from idea to, when your customers have it in their hands and, can give you money or love or respect or, whatever it is that you require in exchange for that product. And the kind of two big numbers on the right that I think are kind of startling too are high performers spend a lot less time on unplanned work, redoing work, fixing bugs late in the pipeline, all of those things, and have 44% more time to spend on new work. Right? I mean, that's competitive advantage right there if you didn't need any other reasons to do this. Now, the 2017 numbers on the bottom here, I'll sort of explain a little bit. The gap between the high performers and the low performers in terms of deployment frequency actually shrank a little bit this last year, which I think is good. I mean, to me, I think that indicates that the low performers are starting to try to catch up. The interesting thing too is the gap in terms of recovery from failure grew. So they're failing more often, which is okay. I mean, the only way to get better is to fail and learn from it, hopefully, and keep it going. But, I was supposed to talk about architecture, so enough about that. That's just a little bit of kind of why this stuff matters, right? So why is architecture important? Well, I'm going to just rely on Martin Fowler's kind of circular definition. Architecture is important because it's about the important stuff, whatever that is, right? Another way to look at it, is it's not the strongest of the species that survives, nor the most intelligent. It is the one that is the most adaptable to change. And that's the part of that sentence I want to focus on. And as my little note says down there, turns out Charles Darwin didn't actually say this in any of his books. And there's a great website called Quote Investigator. So if you ever use a quote in a slide and you're not 100% sure where it came from, might be worth a little Googling there, because that's kind of interesting. But a quote that I do know is real and came out of a book is this one. Software's most important quality is its adaptiveness and ease of change. And this came out of a book or a booklet or a paper, really, done at the DevOps Enterprise Forum 2, maybe 3 years ago. Basically on metrics, right? Measure efficiency, effectiveness, and culture to optimize DevOps transformation. And I'm going to argue, I think I could probably just postulate, right, that software architecture and your software pipeline architecture has a hell of a lot to do with how adaptive and easy it is to change your software, right? Whether it's fixing bugs, adding functionality, fixing performance issues, fixing security issues, whatever it is, architecture plays a pretty big part in that. And then the next two slides I stole from Jez Humble. Without his permission, so sorry, Jez. But they're so good, I had to. So architectural outcomes, right? Because when we talk about metrics, right, we always want to talk about outcomes. We want to measure outcomes, right? We don't want to measure how many tickets were closed. We want to measure, were our customers happy with the resolution of the ticket, right? Because if you just measure things like how many tickets were closed, well, that's pretty easy to game, right? So you don't really want to do that. So architectural outcomes. So all these questions here, right? Can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams, right? Can my team complete its work without fine-grained communication and coordination with people outside the team, right? Can my team deploy and release its product or service on demand independently of other services the product or service depends on? Can my team do most of its testing on demand without requiring an integrated test environment or shared test environment? Can my team perform deployments during normal business hours with negligible downtime? Right? Those are important questions to ask ourselves, right? Because they have a lot to do with, are we able to do DevOps? Are we able to do continuous delivery? Are we able to be as agile at the back end of our process as we may be in the front end of our process? And I did say I stole 2 slides from Jez. Here's the second one I stole. And this is kind of out of the State of DevOps report as well. Loosely coupled architectures and teams are the strongest predictor of continuous delivery, right? And a lot of that has to do with kind of the mythical man month, if you've ever read that book by Fred Brooks. But the notion that you can't just throw additional people at a software problem and expect it to get solved any faster. In fact, if you do throw more people at it, you will solve it slower because of all the communication that has to happen, right? And loosely coupled architectures and loosely coupled teams, it's really just divide and conquer. I mean, that's really the major issue we're going after here, right, is being able to do that. And I'm going to dig into that in some detail. talking about loosely coupled architectures, which is mostly microservices, at least in my experience. So monolithic architectures, right? They've been here for a long time. Certainly they're not completely stupid, because just about every single website in the world was built that way to start with and made tons of money and lots of customers and those things. So kind of prima facie, they're not bad on their own. They can be easier to develop. They can be easier to test. They can be easier to deploy. I mean, if I have a ginormous WAR file and I drop it into JBoss or WebLogic, I've done most of the deployment right there. In contrast to if I go microservices and I've got 200 microservices, and that's going to be a little bit kind of more moving parts. But there's obviously a lot of cons to monolithic architectures. It's a lot easier to produce spaghetti code because you've got a huge code base, and unless you're very careful, very strict, do a lot of code reviews, twist some arms, somebody's going to look at your data structure. Somebody's going to look at your private final member and try to figure out what it is, and all of those kinds of things. It's just easier, and it happens. It's also harder to integrate new technologies, which is very important and very relevant, right? Generally, because if you're going to adopt a new technology, you've got to adopt it for the entire thing, right? I'm not just going to be able to strap on some Go code next to my 5 gigabyte WAR file, and I don't know how you'd make that work. Harder to learn and understand the code, because generally you're dealing with one ginormous code base. Maybe it's well modularized, maybe it's not. It's kind of hard to tell. And the last two are kind of the most relevant these days, I think, which is if you're going to scale anything, you've got to scale everything in your monolith, right? You've got to worry about how all of those things are going to behave when you have multiple horizontal copies of your app in clusters, right? That's a problem. And you can't deploy anything until you deploy everything, right? So if you've got a bunch of people working on changes and they're not ready, but they're checked in and not tested, you can't deploy, even if your stuff is ready, right? Even if your bug fix, your very important security update, your whatever, you can't go, right? Everybody has to kind of get in a room and, are you ready? Yes, I'm ready. Okay, let's go. Let's spend the 8 hours doing the manual deployment now. So those things are, kind of the bad parts about monolithic architectures. Now, microservices, on the other hand, are different, right? Here, the idea is divide and conquer. So we're going to build a suite of services. Each one is focused on doing one thing well, right? And they're independently developed. They're independently deployable. Each one exposes an API and runs in its own process, right? So you might have 5 of these, you might have 500 of these, you might have 1,500 of these. It really just depends on the size and scope and complexity of the application. A common question that gets asked is, well, how big should a microservice be? And I don't think there's a right answer to that, right? You can make them too small, you can make them too big, but probably the bigger mistake is to not make one at all, right? I think I say later on in the slide, like I'd rather have 5 macro services than one monolith. So you got to start somewhere, and there's lots of different ways of going about that. So what's cool about these loosely coupled things, right? So it's divide and conquer, complex distributed applications. Now that doesn't make it easier necessarily, right? I mean, to do microservices, you got to be pretty good at certain things, right? You got to be pretty good at architecture. You got to be pretty good at API design. You've got to be. There's a few things I'll talk about later that you got to be. You got to be really good at doing automated software deployments and automated software pipelines. Otherwise, it will be utter chaos, and you will rue the day that you decided to do microservices. They're independently developed and deployed, and they're an ideal use case for containers, right? Because we want small, one-process things that live on their own and don't care about anybody else, right? So containers and microservices are a little bit like peanut butter and jelly. You have the freedom to choose the right technology, whether it's old or new, for each service, which is pretty cool, right? Because the hot new thing comes down the pike and everybody wants to use it. Well, if you have a use case for it, go for it. A lot easier to do that when you have a bunch of microservices than the monolith, right? The monolith will be written in whatever language it was written in on day one, right? And it will continue to be in that language until the end of time. And, as I kind of referenced before, smaller, more autonomous teams tend to be more productive, right? Less communication, more autonomy, kind of more of a sense of purpose of what it is that we're working on. Doesn't make it easy. There's nothing easy about this, and microservices are not a silver bullet, right? You can very easily take your big pile of crap and turn it into a bunch of small piles of crap, right? That's, not difficult to do at all. So there's nothing magic about it, right? There's a lot of hard work, some tough design decisions, and that kind of stuff that has to happen for you to be successful with microservices. Go into it with your eyes open. Read the war stories, read the blogs, read what people did and screwed up, and all of those things. And I'll talk about some, well, mostly about good things, not so much about bad things. So some best practices if you're in the business or want to be in the business of decomposing your monolithic app. Now, this is a little bit of a wall of text. I apologize for that. But so you want to kind of start with identifying what can we migrate to microservices, right? And that could be maybe some new work that you need to do, some new functionality that isn't in the monoliths and has an opportunity for doing something in a separate service. It could be something that you need to do that really does require some slightly different technology than what you have in your monolith, and so you really can't build it in there. There's lots of areas that you can sort of start to look for seams or look for opportunities to start to either peel off some functionality or come up with some new functionality. But you really, you want to think about it in terms of, independent chunks of functionality, right, that are focused around some single capability. It's not uncommon to see sort of a one-to-one mapping between service and table if you're using RDBMSs. Maybe that's a little oversimplified, but it's pretty close. The strangler pattern, if you're not familiar with that, Google it. Hopefully that doesn't bring up anything too odd. Sorry. But use the strangler pattern liberally, right? I mean, put something in front of the monolith that can be kind of a little bit of a traffic cop to send certain API calls or certain things off to your new service, right? Maybe not all the traffic at first, maybe just some. Maybe you want to split the traffic and send it, there's a lot of good talks and a lot of good blogs out there about kind of how to start bootstrapping this, how to get it up, how to test it, and how to send real data to it, which are good to do. Domain-driven design, I've seen lots of people talk about that and recommend that, especially ideas like domain contexts and aggregates, which aggregates are really just kind of an entity object that has a single root. It may have other objects that it owns, but they kind of share the same life cycle. That's a good kind of chunk to put off into its own service. You'll get it wrong the first time, so just accept that and move forward. It will be expensive to, in the future, reorganize all your APIs, right? So do give some consideration to that up front. In fact, one of the most common pieces of advice I hear is, if you're starting fresh, if you're not trying to decompose an existing product, start with a monolith. Don't go creating 50 microservices on day one, unless you've done this before and you understand the domain really well and you've made mistakes before and you know how to correct them on all of those things, right? My goofy analogy for this is, it's kind of like when somebody puts up a forum, like, an internal company forum or something, and they pre-populate it with 52 different topics, right? Everybody ends up using the general discussion topic and everybody ignores the other ones, right? That's the risk you run if you sit down and say, well, here are the 50 services I think we need. We need the service for left-handed people, the service for right-handed people, and you can quickly go down the wrong road of that. And it is expensive to shift those things around after you're in production, right? Shifting the boundaries of these APIs and domain objects and those kinds of things will not be cheap. So you want to try to get that as right as possible. So if you're starting from scratch, stay monolithic for a while until you feel like you have a little bit of an understanding of what the domain is. Don't boil the ocean. Do this as an agile project. Bite off a little bit of a time, small batches, lean, all of those things. Benchmark early, right? Because you're going from probably a situation where you're making a method call, which is these days essentially free, to where you're going to make an over-the-wire call, which could fail, could be slow, could be held up by DNS, could be held up by packet collisions, could be held up by somebody tripping over a network cord, all kinds of things, right? So you want to benchmark and understand, and not be in a situation where 6 months later we've got our 50 services stood up, and what used to take 100 milliseconds now takes 100 seconds. because we're talking to 100 different services to do that thing. That is a risk that you run when you start to decompose these things. So benchmark against that. Conway's law, pay attention to that. Any system will tend to reflect the communication or organizational structure of the team that builds the system, right? If you want a 4-phase compiler, have 4 teams build a compiler, right? That's sort of the inverse Conway's law. Dependency analysis tools like code dependency analysis tools can help, but they're not a panacea. It can help you start to draw some hard boundaries through the code of where things happen, but that doesn't tell you anything about what's really, I'm afraid, going to be the most difficult and onerous task, which is how do you deal with state, right? Or as we like to call it, data, the database. That's typically one of the most difficult things to deal with. It is a huge source of coupling, right? Every foreign key that you have in your database is a potential source of coupling, right? Now, if that's a foreign key from a line item in an order, that's probably not such a big deal, right? Because we can think of that order and its line items as a single kind of aggregate domain object. But and I'll get into some examples here in a second, but the foreign key from the order to the customer table, that may not be such a good idea, right? And there's all kinds of tricky things to work out in that. Understand where you have shared mutable data, right? And if you've already horizontally scaled your monolith, you may have thought about a lot of these problems already, which is good. There's lots of different things that you can do around those kinds of things, optimistic locking and those types of things. Where your transactional boundaries are going to be tricky as well. So to the extent that you can understand those up front, good. You may have to reverse engineer that, right? Depending on the age of this code and how well maintained and documented it is, and if the people that wrote it are still around and all of those kinds of things. You may need to consider eventual consistency, right? Because really, with databases, the CAP theorem, you're going to get consistency and availability and performance, pick any 2, right? You're not going to get all 3. It just doesn't work. So you may need to deal with situations where something happens, but the reflection of that in the output doesn't happen right away. I'll get into that a little bit later as well. Avoid distributed transactions because they are not going to help you scale. They're going to sort of do quite the opposite. And quite frankly, if you're dealing with things like third-party APIs and those kinds of things, you're not going to participate in those transactions anyway, right? So that's not going to happen. You'll probably find that there might be a lot of messaging between services. Some of the patterns I'm about to talk about use messaging quite liberally. You may even want to think about splitting your data before you split your code, if only as a kind of a thought experiment, right? Code is fairly easy to refactor these days, right? The IDEs are kind of good at doing that stuff for you. What used to take us all night just to rename a damn class, now gets done in 10 seconds and boom, it's automatic and it renames the files and tells the SCM system and it's awesome. I love it. That used to be such a pain. But if you can split your data and start to kind of get a little bit rigorous about that before you start to split your code, that could help too. Now again, that depends on the scale of the system and all of those kinds of things. And do you really need an RDBMS? Do you need ACID for all of these things, right? You may not, And in fact, ACID will make it very difficult for you. I can't believe I'm saying that. ACID will make it very difficult for you to decouple, right? Because if you need that sort of transactional consistency, you're going to have to find new ways of doing it. And I have a couple of examples of how to do that. And actually, the last line there, Saga, event sourcing, CQRS, are 3 attempts at kind of getting over this. Not necessarily the end all and be all. But let's look at some of those. So here's an example of just a very simple, couple of microservices, right? So we used to have an order table and a customer table. And when we created an order table, we do a credit check against the customer. And if the credit check fails, then we fail that transaction or return an error or say, sorry, you need to give us more money first, right? Easy to do in a monolith, right? Because I can do that all in a transaction and commit it and it's atomic and we're happy, right? Now, a couple of weeks later, we're doing microservices and we now have an order service and we have a customer service. And we don't know, as a consumer of that API, how that data is stored. We shouldn't have to care, right? They might be stored in 2 tables in an RDBMS. They might not. They might not even be stored on the same kind of technology. We just don't know. Now that leads to some problems, right? The first problem is, how do I do a consistent update, right? How do I make sure that when I place an order that I don't exceed the credit limit when I can't do that, right? I can't do that as one thing. And I don't want to use two-phase commits, right? I don't want to do distributed transactions. It's not me. You don't want to do two-phase commits. I don't, go for it. So one of the patterns is the Saga pattern, which is basically kind of turning this into a little mini workflow, right? So the way it would work is we'll do multiple transactions. And each transaction will also commit an event that will cause further transactions to happen. So in this example, on the left side here on the bottom, in the order service, we'll create a new order, store that whatever way we store it. We'll set its status to pending. And then we'll send a message to the customer service and say, hey, this customer just submitted an order. Here's the order ID, here's the amount, yada, yada, yada. The customer service takes that, looks at the customer's current credit limit, looks at the order, and then either sends back an order rejected event or an order accepted event to the order service. And at that point, it can update the order status to rejected or approved, and other things can happen, right? So that is one pattern where you can start to break apart the coupling that you have in your database with a combination of persistent messaging and perhaps even RDBMSs, most likely even RDBMSs on the back end. Now there are some downsides to this, right? It's a more complex, different programming model, right? Because a lot of things that you're doing in business logic today, which is just 6 lines of code like this, and boom, it's all inside the same transaction, happiness occurs, now becomes a little bit more tricky, right? Because you have to split that into 3 separate things with some messages in between. Now there's frameworks out there to help do this, and so on. So that may not be as bad as it seems. Probably the more tricky thing is what to happen when there's a failure of some kind, because you may need to write, there's no rollback here, right? By the time we get 2/3 of the way down, we've done 2 commits to the database, and we have no rollback. So we may need to write compensating transaction, that seems to be the phrase that people use for this, to kind of undo things. And so we may need to have, kind of similar to the way a distributed transaction manager would work, every once in a while you kind of got to go and clean up stuff, right? Now hopefully you have a durable enough system that doesn't happen, but that could definitely be a failure mode. And the tricky thing, and this is coming up some proposed solutions or patterns for solutions coming up in future slides, you're going to need to be able to atomically commit the transaction that changes the data and post the event, right? That has to be atomic, because if we lose that event, we lose, right? We now have an order that's stuck in pending forever, because that event got dropped on the floor and nobody's ever going to check the credit limit or anything. So we've got to kind of come up with a way to solve that problem. Which I'll get to in the next slide. But first, I'd like to be able to do something like, give me a query that sorts by region the customers that have ordered more than X amount of dollars worth in the last quarter, right? Now, to do that in a standard monolithic application, easy, SQL, join, group by, max, min, count. You can't do that now, right? Because you don't have access to that. You can't do a join. Right? So you've got a bunch of options. One option is just load all the data in some aggregate service and then do the stuff in memory there and then give an answer. That seems kind of kludgy to me. Seems like that wouldn't scale very well. And now you've coupled again, right? Now you've taken the order service and the customer service and you've created the customer order service, which, once you add another 50 services, I don't think that's going to scale. So one pattern that I've seen out there, and again, you can go use these patterns and screw up completely. So don't blame me if you do. But just sort of some suggestions for how to do things. People have succeeded with these. So the command query responsibility segregation, which is a really long-winded, weird way of saying we're going to take CRUD, create, read, update, delete, and we're going to take the R and do it separately. Right? So we're going to have one service over here on the left whose job it is to create, update, and delete data. Right? So it owns that data. It owns all modification to that state. As a side effect of that state modification, it will publish events about that modification, about that state mutation. And then, as you can see kind of on the right here, you can use whatever technology you want, whatever technology works for answering the types of queries that you need to answer, right? You could shovel all that stuff back into a relational database and just do a simple join, right? If that's what makes you happy. Or you can, use Mongo or Elastic or, and do any kind of, crazy queries that you want. And if you need to do dashboarding and do lots of kind of reactive and happening user interfaces, this can be pretty cool because you can sort of very cheaply on the fly compute the answer to all the important queries that you want to show. Of course, assuming that you know what the queries are up front, which sometimes you do, sometimes you don't. So really, that's really just saying, look, let's take the mutation of state and have it be separate from how we query that state. Now, that leads to some complexities, right? That probably means that when I write that state, when I make that ask of the service to modify something, I can't immediately read it back, right? So now again, I'm in that sort of multi-event-based kind of way that I have to program. And if you've ever done event-based programming, this will feel very, kind of familiar and at home to you. But the nice thing is it can scale massively, right? You can really separate the concerns between reading and writing. And that can be a very good thing when it comes to databases. But again, complexity, right? But there ain't no such thing as a free lunch. I'm sorry. You need to be okay with eventual consistency because there's going to be lag here. Now the lag might be 1 millisecond, or it might be 1 second or 10 seconds, right? That all depends. So you need to have some sort of way in your user interface, let's say, that when I click, click the order, that the update reflects the correct state of the system, right? So I may need to be able to say, I want you to give me the state of the object after this point in time, and just don't give me anything until that data shows up, right? So then my order comes up, those kinds of things. So there is definitely complexity in doing all these things. And quite frankly, using a reporting database or a database warehouse might be an easier way to solve this problem, right? If your problem is, I'm writing a lot of data, and when I run expensive queries against it, it screws up my write performance, right? Maybe all you want to do is just, shovel off and partition that data into a warehouse and do the reporting there. But that may not work if what you want is sort of a real-time reactive interface that the users are using, and so reporting databases are great at batch reporting and those kinds of things, not necessarily for the real-time stuff that everybody wants. And then there's a real crazy harebrained solution, which I find really fascinating because it turns out that I've actually used it and didn't even know. Event sourcing. So the idea with event sourcing here, first of all, one of the problem we're trying to solve here is, so I need to be able to commit some change to state, right? And I need to broadcast an event telling the rest of the world that I made that change. But I want to do that again without two-phase commits, without distributed transactions. So the idea here is we will persist our business entities as a sequence of mutating events, right? Create, updated this column, updated this column, updated this column, deleted it, that kind of stuff. Either instead of storing it as a row in a database table, or in addition to storing it as a row in a database table. And one of the benefits you get out of this is you sort of get an audit log for free. And I wrote hibernate-nverse there. If you've used Hibernate, nverse is the module that does change tracking. And it pretty much implements this, right? Every time you have a mutation to a domain object, it inserts a row in a history table. Create, update, 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 delete. Create, update, 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 delete. And there are cool properties of this, right? Aside from sort of the audit log perspective. You could do point-in-time queries, right? So I can ask for the state of an object at a particular point in time. Now that may be useful to you, or it may not, but it is definitely something that you can do. And that's kind of how the Hibernate change tracking mechanism works. I'm probably grossly oversimplifying here. But there are challenges to this too, right? I mean, this is a pretty weird way to do things from the perspective of, okay, now I really need to do something like the command query segregation thing, because I can't query these tables. It's going to take me forever to, add up all of those things. Or I need to do some sort of snapshotting mechanism where I collapse a number of events into sort of one event, and then I need to manage that, and so this gets complicated. You probably don't want to build your whole system on it unless maybe it's kind of the change tracking part of it. But it is a way that you can use, you essentially end up using that database table as both the state store and the event queue. And you get to commit the state change and, quote unquote, send the event at the same time in the same transaction atomically, which is not just a good thing, but a necessary thing. So those three things, the Saga pattern, command query, responsibility segregation, and event sourcing are ways that people have kind of approached the problem of how do I decouple the database. And now that I have done that, and I can't use joins, and I can't do atomic commits of multiple pieces of data at the same time, and so on, I need other, we need other techniques of doing that. Some other things that I've run across, BFF, not best friends forever, but backends for front ends. And really the idea here, and SoundCloud has some great blogs and presentations they've done on their efforts in this. Really, it's kind of a variation on API gateways. So the idea is that there's some sort of service that you talk to, which is in the case of what SoundCloud did, is tailored for whatever client device is accessing the service, right? And that makes a lot of sense because, if I'm sitting here on my laptop, plugged into power, wicked fast Wi-Fi here at the Hilton, I don't care if I send 50 requests to the back end and get a bunch of data back and present it and make it nice. But if I'm on the airplane with my iPhone and my Wi-Fi, the wickedly fast United Wi-Fi, God, I long for Hilton when I'm on an airplane, then I may not want to do that, right? That's going to cost me power, right? I'm going to suck battery doing all those queries and requests. I may not want to bring a lot of data back. I may, in fact, want to aggregate a bunch of data in this BFF and then send that aggregation out back to the client. And so this is showing up quite a lot, right? I mean, API gateways are sort of a thing. That's probably something else to investigate, but I didn't include that here just for time reasons. But the idea is, you kind of aggregate APIs, and they can actually be a pretty good place where you can apply the strangler pattern as well. In fact, SoundCloud did that. They started out with a monolith and then started building these kind of client-specific services, and eventually, started shunting all the traffic to the new microservices code instead of the old monoliths. So that's another thing to kind of keep in mind as you go. In a slightly different direction, and honestly, I don't know how I feel about it, which probably shows up in the next couple of slides. But so serverless, and I find serverless kind of breaks down into two things. One is kind of back-end as a service, where I just buy whatever I want from you, right? Database, messaging, storage, API, authentication, risk rating, whatever it is, right? So it's outsourcing, right? I'm just outsourcing a bunch of, this is the API economy kind of thing that a lot of people talk about, right? To me, that's the less interesting part about serverless. The more interesting part, I think technically, will be kind of the function as a service, right? Or, maybe we'll call them nano services or femto services or, Planck constant services or something like that. I'm probably annoying all the physicists in the room now. And there are physicists in the room because most physicists become programmers, I've realized. Most maybe, and maybe that's too strong. Several of my friends. So this is AWS Lambda. This is really you're not deploying a service. You're not deploying an application. You're deploying a chunk of code, a function. Takes an input, gives an output, and that's it. And it doesn't turn on or turn off or anything. It just, when it gets called, it does its thing and then it goes away, right? And so this is really a different way of thinking about the problem. It's obviously ridiculously easy to scale massively if you need to do that, assuming, again, of course, that state manipulation is not going to get in your way. All things are easy if there's no state, right? I mean, there's only, I forget who told me this, but there's only two hard problems in computer science: naming things and when to flush the cache. If you can solve those two problems, you're done almost. So the code just sort of lives there until something happens to trigger it, right? An event happens, or a file in S3 is modified, or a cron job kicks off somewhere, or a message gets intercepted, or something like that. But it's a very different programming model, right? It is way more functional. It is way more I mean, I think what would scare me about this a little bit, and I actually saw a couple of blog entries on this, is like, is this stored procedures all over again? Right? Which, I mean, the bad part about stored procedures is proprietary, hard to maintain, totally and completely and utterly opaque to everybody in the whole world. Except, yeah, we got 6,000 of them, and that's our system. Good luck figuring out what actually happens and what it actually does. I don't think that's going to be the case, right? Because I think with function as a service, we're dealing with, JavaScript and Java and Python. You get to write the thing in the language of your choice just about these days. But it's a very different way to do this. And this was a great Twitter exchange. If you think serverless is different than PaaS, then either you or I have misunderstood what serverless or PaaS means. And I think Adrian's, if I may call him Adrian, his response is great. If you can start that instance in 20 milliseconds and then tear it down in half a second, you can call yourself whatever the hell you want. And that's really kind of the key. And then Charity Majors did apparently a great talk on this a little while back. She's a little bit more skeptical, although I'm probably painting this as a little bit more skeptical than she really is in the blog entries she wrote about it. So go check out the source. But basically, how hard can it be to just glue together a bunch of APIs that other people wrote and take care of and scale? And and she goes through a lot of things. And what it comes down to is kind of that quote on the right, which is, figure out the things that you care about. Figure out the things that differentiate you from your competitors and make your customers happy, and then own the shit out of those. Right? And if you can do that, and do that as Lambda, if you can do that as serverless, then more power to you. But there are risks there, right? If that doesn't work the way you want it to, or if you start consuming more resources than you're supposed to, then they're going to protect themselves and the other customers from you by shutting you down, right? And I think still now, AWS Lambda, if you run for more than 5 minutes, you get terminated. Right, so it's not appropriate for anything that's going to be sort of long-running processing, image stuff or what have you. And then the ubiquitous question always of, okay, what about state? State. If only we didn't have state. If only everything was stateless, things would be so easy. So I think there's a future there for Lambda type stuff. I think there is going to be interesting stuff that happens there. It's going to make deployments kind of interesting. It's going to make version management kind of interesting. If we think that, that's essentially, one way I think about that is it's not just a microservice, but it's a service per API call, essentially, right? So that's even more granular than a microservice. So then a few odds and ends that some people call design, some people call architecture, some people, I don't care what, but it's important. Monitoring, especially if you're going to go microservices. You better be good at monitoring, or you better get good at monitoring. Or you're going to be, we replaced our monolith with microservices so that every outage could be more like a murder mystery. That's, if you haven't read Honest Status Page, it's sometimes brilliantly funny. And there's obviously a lot of tools out there for doing that kind of stuff. And there are best practices for monitoring, right? Log and emit monitoring data in a consistent fashion, no matter what technology stack you're using. Log early, log often. Aggregate the monitoring into a single place so you can, you don't have to go hunt for it. Correlation IDs can turn out to be pretty interesting when you're, and some monitoring tools will actually inject correlation IDs into requests for you. But if you're dealing with request IDs and things like that, but your incoming API call to your gateway turns into 50 different calls on 50 different services on the back end, and something goes wrong, how do I pull that thread? How do I get those 50 requests out as, one bucket of glop that I can then kind of examine and figure out what went wrong? So correlation IDs are one way to do that. Basically, just stick a header in the HTTP request on inbound, make sure that header travels along with any other requests that spawn off of that, so that you can do that. Monitor latency and response time between services, because again, what used to be a free function call is now over the wire, no longer free. Monitor early, like monitor while you're testing, right? Understand how your system behaves under very controlled, almost ideal conditions, so that you know a little bit more about what it's going to look like when it's running well, and you can tell when it goes wonky. Now, obviously, monitor host, CPU, memory, all of that kind of stuff. And then this picture, just because I love it. Please check the load balancer. Beware of containers. I had a whole section on containers, but I cut it for time. Containers are cool, use them. That was basically it. Architect for automated testing. I say this often in my presentations. If you're still doing manual testing, put your pencil down, stop listening to me, and go figure out how to stop doing manual testing. That is probably your biggest constraint to progress, right? I mean, if you have a 24-hour build process and then a 6-week manual testing process, I don't care how fast you make your software pipeline, that is not your constraint, right? Your constraint is that 6 weeks of manual testing. So put your pencils down. But again, right? Lots of unit tests, less integration tests, less acceptance, less the sort of the test pyramid, which I forgot to attribute who came up with this one, which I should fix. You might want to use separate pipelines for end-to-end tests. They tend to run a little bit longer. You might want to run them in parallel with a bunch of other stuff, all of those kinds of things. And flaky tests are the devil. So that's software architecture. Now, pipeline architecture matters too. Or if a tree falls in the woods and nobody is around to hear it and it hits a mime, does anyone care? As Gary Larson said in one of his cartoons many, many years ago. And what I mean by that is, so we all have software pipelines, right? For some people, the software pipeline is named Sam, and he's the guy that does the build and does the release and pushes the bits. And if Sam is sick, we don't release. If Sam is on vacation, we don't release, right? If somebody forgot to do the testing before Sam pushes the button, oops, right? So we all have a software pipeline. What I'm going to argue for is that we should all have automated, no-touch software pipelines, right? Software delivery has changed. We've gone from few releases with large stuff to tons of small modular apps, lots of releases, all of those kinds of things. And we're dealing with many architectures, many pipelines, many destinations, right? Hybrid architectures as we're trying to break apart the monolith, pure new, pure old, everything in between, basically. And then, that's going to get deployed into lots of different places. And a quote from Jez Humble down here, which I think is a massive understatement in some ways. Bimodal IT, which is a Gartner term, I think, so I don't want to be too evil to Gartner, but is a massive reductionist oversimplification. I think at best we're dealing with multimodal IT maybe or something like that. It's tricky. So lots of different pipelines that we need to think about, right? Commit pipelines or CI basically. Dev, build, test, those kinds of things. And we do lots of things in those. We might even need to provision environments, configure them. We probably need to deploy our code to them and then tell the testing system to run the tests, collect the data, so on. Get the human out of the loop there. That's not what humans are good for. We suck at typing the right command into the right xterm window at the right time. At least I do, and I think there's significant evidence that you all have that problem too. So then we have things like release pipelines, and we might even have multiple commit pipelines, right? Because we're going to have, in our microservices world, each microservice is going to have its own pipeline because it needs to be independently developed and independently deployable. Now, that doesn't mean that you don't want to have sort of a release pipeline, because maybe you need to do some integration testing, maybe you need to do some verification before you kind of push into production. And similarly there, you're gonna provision, configure, deploy, all of those things. Your first deploy hopefully is not into production. Your second deploy is hopefully not into production. Maybe your 100th deploy of that code, maybe that should be into, because developers should be deploying, QA should be deploying, or have deployments done on their behalf, all of those kinds of things. Your software pipeline is a pretty critical feature of your software, right? If you don't have it, whether it's Sam who pushes the button or your wonderful new automatic software pipeline, the code doesn't make it to the customer. No value is generated. Again, the tree falls in the woods and hits a mime, and does anybody care? So I'm going to race through these things here. So some best practices, and these are fairly kind of standard stuff. So have an artifact repo, right? One of the earliest things that showed up in the State of DevOps report was that having an artifact repository, binary artifact repository, was a leading indicator of DevOps-ness, if that's a word. Maybe I just coined that. So have an artifact repository. Don't just dump things into a shared folder, right? Auditors, although auditors love when you dump binaries into random public folders and anybody can read them and write them and change them, and yeah, they love that stuff. Automate your deployments. I'm going to use the word automate a lot in the rest of this here, just be warned. Automate and smoke test your deployments, right? No human touch. You may want to have a manual gate at some point where we all, kind of do the secret handshake and the Buddhist priest comes and we release, but automate as much as possible. Don't just have everything be manual. Self-service deploys are a pretty big deal. If I'm a QA person, I shouldn't have to be hunting after people to get them to deploy product on my behalf, right? That should be self-service. And maybe you want to have a self-service catalog with all the, here's the 12 approved ways that we do deployments of our code. If you want to be number 13, talk to us and we'll set up number 13 for you. But if you want to do it one of the 12 pre-approved ways in company X, then push the button and you're done, right? That's what it ought to be. Similarly, for environments, self-service environments, right? Whether that be a bunch of cluster stuff up in Kubernetes or OpenShift or Google Container Engine, or whether it's VMs in Amazon or what have you, self-service environments that deploy automatically, come out of a catalog, so we still have governance, we still have control when we need that kind of stuff, and then deprovision them when you're done, so that we don't have sprawl of all that stuff. It is no accident that EMC, a storage company, bought VMware, a virtualization company, because they knew that the one thing you're going to need when you have tons of VMs is a shit pile of storage, right? That was no accident. That was no accident. Security, auditability, governance, all of those kinds of things. One of the nice things about automation is, again, grossly simplifying, what does an auditor want fundamentally? Document what you do, prove that you did what you documented, right? Again, grossly oversimplifying. Well, an automation definition is kind of the documentation of how you do things. The runtime record of that automation is the proof that you did what you documented, right? Now there's more to it than that, but that's a lot easier than, and then we copied it into this public folder and we renamed the file to this, but the name was wrong, so I had to go back and change it, that auditors don't like that. Bunch of other things that I put up here. Automate all the things, don't do manual handoffs. Manual handoffs are for chumps. One interesting thing to keep in mind is if you do automate your software pipeline, that's going to have to be probably at least as available and reliable as your product. Because if your product is down, the pipeline better be up, because otherwise how are you going to fix the product? So think high availability, think disaster recovery, all of those things, because your auditors will ask you about that if you're in one of those fun regulated industries. Don't tie your software pipeline architecture to your software architecture, right? And maybe, I'm not saying don't do it, but keep in mind that if you do that, if you go with a container-only way to deploy, and you suddenly decide sometime in the future that containers are so totally 2017, we're going to use something else, now you've got to change your software pipeline as well. So try to be, go with Switzerland or Sweden of deployment tools. Hint, hint. Are your tests automated, really automated? Like really, really, really automated? Again, if they're not, put your pencils down, stop listening to me, and go automate your test. Self-service, chat ops kind of approaches are great for onboarding, right? Teaching people how we do things, how things are done, those kinds of things. It's great to get a real-time view of kind of what's happening in all of your different pipelines and how they fit together. Excuse me. Plugging the pipeline into monitoring is a good thing too, right? Even if you're just doing things like blue-green deployments into production, or maybe not even into production, you kind of want to turn off the monitoring on the thing you're about to turn off before you turn it off to avoid all the red lights going off and the excitement that happens when that happens. So think about that. Allow for automatic and manual approval gates, all of those kinds of good things. And then build reusable models for this, right? If you're going to have 200 different microservices, you probably ought not to have 200 completely different pipelines, right? Yes, maybe you're using 5 different technologies, and maybe you will have 5 different types of pipelines, right? But build for reuse, build for, be smart. Last kind of slide here before I finish off. Just a simple, container release pipeline, just to give you a little bit more of a picture, right? So dev stage, QA stage, staging, production. And really, the two on the left are kind of the interesting ones. So we're building for a container, right? Excuse me. We do a git checkout. Maybe we do some code scanning. Do some vulnerability assessments on our code. We do a Docker build, produce the image, run some unit tests on that. If they pass, we push up to our Docker registry, and then we're done with the kind of the dev side of things. Now we go to the QA stage of our pipeline. Maybe we run twist lock and do some security verification on our Docker image. Review security vulnerabilities to see if there's anything new we need to worry about there. Deploy this thing, do some test automation, start monitoring all of those things, and then automated or manual approval gates as you kind of go further on into higher environments in your pipeline. But I just wanted to put that up there as kind of more of a concrete picture of what it can and does look like when you automate it. And then the eye chart. This is just a list of all, well, not all, but many of the blog entries and papers and posts that I shamefully stole most of this good content from, well, to the extent that it was good. So feel free to take a picture of that, or I'm sure the slide will be available later on. So with that, happy to take any questions if you have them, or I know drinks are going to happen later tonight, so I don't want to stand in between that. So, but that's why I'm up here, not in the back, right? And if you don't want to ask a question in open, you can come up after we're done and chat with me as well. But thank you, everyone. Thank you very much.